In this video series, I work through a math problem or problems each video. When solving a problem with a quadratic equation, we first write that equation using the information given in the word problem, then solve the equation for x using the methods studied in the previous videos. Let's take a look at the example. The length of a rectangular area is 14 inches longer than its width. The area of this rectangle is 1800 square inches. Find the length and the width of this rectangle. In this problem, we need to find two values, the length and the width of the rectangle. Let's go ahead and use x to represent the length of the width, and x plus 14 to represent how long the length is. We find the area of a rectangle by multiplying together the width and the length together. So that's x plus 14 multiplied by x, and we're told that this is equal to 1800. We first multiply x to x plus 14, which gives us x squared plus 14x. Then we subtract 1800 from both sides of the equation. And that's equal to 0. Now we need to factor the expression on the left-hand side. And since the coefficient for the quadratic term x squared is 1, we get x and x. And we just need to find out what the other two numbers are. So to do that, we need to first factor 1800 into prime numbers. (1800) is equal to 18 times 100, and 18 is equal to 2 times 9, and 9 is equal to 3 squared. And 100 is equal to 10 times 10, and each of those 10s are or is equal to 2 times 5. So 2 times 5 times 2 times 5, we can rewrite that as 2 squared times 5 squared. 2 times 2 squared is 2 cubed. We get 3 squared and 5 squared. So 1800 factored into prime numbers give us 2 cubed, 5 squared, and 3 squared. So 2 cubed multiplied by 3 squared multiplied by 5 squared. If we write out all the factors of 1800, that's going to be a lot of factors. So let's go ahead and see if there's a way to eliminate at least some of the answer choices so that we don't have to check as many possible factors. So the way we're going to do that is by looking at the linear term 14x. This number 14 holds a key to helping us eliminate most of the possible factors. We know that we're going to be factoring these prime numbers into two numbers, and once we write these factors, we need to let's see, since the sign here is minus, we're going to be subtracting one of the factors if we consider them to have the same sign, or if with the sign included, they're going to have opposite signs. So when we add these or combine those two factors together, we're going to be either adding or subtracting them. And we need to end up with 14, which is an even number. So if we think about all numbers or all integers, they're either even or odd. So the two factors will be either even, 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 odd, or odd, odd. If we have one even and one odd number, they're gonna either add or subtract together to get an odd number. And that's 14 isn't an odd number. So that means that the two factors must be either both even or both odd. Now, the problem is we have a factor of 2 here, 2 cubed. That means that it's going to force at least one of the factors to be even. So we can't have an odd, odd as the two factors. So we eliminated odd, odd, and odd, even. That means that both of these factors we're going to be writing out should be even. So both of them get at least one factor of 2. And the other factor of 2 need to end up with either of the factors, one of the two factors. So let's say we're going to choose this factor to get the other factor of 2. So the two factors that we're looking for will have 2 and 2 squared as part of it. Next, let's take a look at just 3 squared. We can imagine either dividing up 3 so that both of these numbers get 3, or we keep 3 squared so that if this factor gets 3 squared or this factor gets 3 squared. If we take a look at 14, it isn't a multiple of 3. If we divide up 3 so that both of these factors get 3, then both of these numbers will be multiples of 3. And if we add or subtract multiples of 3 together, the sum or the difference of those two numbers will also be multiples of 3. So we can't do that. We need to make sure that 3 squared stays together. So either this first factor gets 3 squared or the second factor gets 3 squared. And since 14 is not a multiple of 5, we can use the same reasoning to say that either this factor gets 5 squared or this factor gets 5 squared. And the final thing is 14 is a relatively small number. So more than likely, we're not going to keep 3 squared and 5 squared all together and give it to one of the factors. Either this first factor gets 3 squared and the other factor gets 5 squared, or this first factor gets 5 squared and the other factor gets 3 squared. So let me go ahead and write both of those possibilities out. So this gets 3 squared and this gets 5 squared, or this gets 5 squared and this gets 3 squared. Okay, and let's write this out. 2 times 3 squared, which is 9. 2 times 9 is 18. And 2 squared is 4. 4 times 25 is 100. So if we get 18 and 100, 100 minus 18 is equal to 82. And that doesn't match 14. So this isn't the factorization we're looking for. If we multiply 2 and 5 squared, which is 25 together, we get 50. And if we multiply this out, 2 squared is 4, 3 squared is 9, and 4 times 9 is 36. 50 minus 36 is 14, which is what we want. So when we factor our polynomial, we get 50 and 36. 14 is positive, so we need to make the bigger number positive. So x plus 50 and x minus 36. Now that we've factored this polynomial, we can just go ahead and set each of the linear factors equal to 0. Then solve each of these equations for x. Since length are positive, we can eliminate the answer choice minus 50. So we know that the width is equal to 36 inches in length, and the length is 36 plus 14, which is equal to 50 inches long.